Okay, today we're going to talk about the cubic function, and we're going to talk about using explicit and recursive form again. So each year, Scott participates in the Macho March promotion. The goal of Macho March is to raise money for charity by finding sponsors to donate based on the number of push-ups completed within the month. Last year, Scott was proud of the money he raised, but was also determined to increase the number of push-ups he would complete this year. So part one, revisiting the past. Below is a bar graph and a table Scott used last year to keep track of the number of push-ups he completed each day, with day one showing he completed 3 push-ups, day 2 he completed 5 push-ups for a total of 8 at the end of day 2. Scott continued the pattern seen in the bar graph throughout the next month. Below is the bar graph and table Scott used last year to keep track of the number of push-ups he completed each day, showing he completed 3 push-ups on day 1, 5 push-ups on day 2 for a combined total of 8 push-ups. Scott continued this pattern throughout the month. So here's the pattern and there's the table. So question 1 says, write the recursive and explicit equations for the number of push-ups Scott completed on any given day last year. Explain how your equations connect to the bar graph and the table above. On what day will Scott do over 100 push-ups for the first time? So looking at the explicit, so remember we can use our table to help us, and we can use the bar graph as well. So the first thing we want to do is look at the difference. So if I go ahead and subtract, because we're going to look at the push-ups given on any given day. So 5 minus 3 is 2, 7 minus 5 is 2, 2, and 2. Remember, that means this is a first difference, and we just talked about the fact that means this is going to be linear. And so we want to find the explicit and recursive pattern. So the explicit pattern, remember, use your calculator for. So in our calculator, we go to, remember, stats, enter unedit, and we can clear out list 1 and list 2. So list 1, excuse me, we just need to add the 4. And list 2, we're going to put the how much we have in each bar graph. So 3, 5, 7, 9, and I guess we could do 5 as well because it's in the table. So 5 and 11. And then remember we want linear, so stat, right arrow to calculate, number 4, and then go down to calculate. So 2 is A and B is 1. So remember that means this is 2 and plus 1. So A sub n is equal to 2n plus 1. And the recursive form, remember, you have to state the first term. So the first term we know is equal to 3, and the nth term is equal to the previous term. And what are we doing to the previous term? We're adding 2. And so notice that the rate of change is constant. So when you have a linear equation, you have a constant rate of change, which we've talked about in Math 1 with the slope. So if we want to figure out what 100 push-ups is, remember we have to use the explicit recursive. You would have to find all the terms up to the 100 term, which would take a while. So let's go ahead and use the explicit form. So on what day will Scott do over 100 push-ups? So that's saying our n term is 100, and we're solving for n. So subtract the 1, divide by 2, and we get 49.5. So that means Scott's will do over 100 push-ups on day 50 because we want over 100. So on day 50. For the next question, it says we want to write the recursive and explicit equation for the accumulated total number of push-ups Scott completed on any given day during the Macho March promotion last year. On what day is the cumulative total number equal to 80? So if we go up here to our table, we're using the number of days and the total number of push-ups in the month. So we're going to go ahead and find our difference first. 8 minus the 3 gives us 5. 15 minus 8 gives us 7. 24 minus 15 is 9. And this would give us 11. So the first difference is not the same. So we go ahead and subtract again. So this would be 2. 9 minus 7 gives us 2. 11 minus 9 is 2. So that means this is a second difference, which we know is quadratic. And so we want to find our explicit equation. So in order to do that, remember we use our calculator. So stat, enter on edit, and we're going to keep list 1 the same, and for list 2 we're going to use those cumulative totals. So 3, 8, 15, 24, and 35. Stat right over to calculate. Now we're doing quadratic, which is number 5, and we're going to calculate. So we get 1, 2, and 0 for our A, B, and C values. So for this, if you go back up here, it's using T of n, so we're going to use that. This one was using A of n. So the total number, so T of n, is equal to n squared, because remember our A was equal to 1. B is equal to 2, and C was equal to 0. So let's go back and look, see, 1, 2, 0. So n squared plus 2n is our explicit form. And then why don't you guys go ahead and, practice doing the recursive on your own, and then when you're done, pause to see if you get the correct answer. So remember, we have to state our first term, t of 1 equals 3, and the formula for the nth term, so t of n is equal to the previous term plus, and then if we go back up here, remember the second difference was 2, so this would be 2n, so 2n plus something. So remember that to find that something, we are going to use our second term. So we're going to do n equals 2 and plug that in for our n values into our equation to solve for this. So t sub 2 is equal to t sub 2 minus 1 plus 2 times 2 plus something. If I go back up to my table, t of 2 is equal to 8. So I'm going to substitute that in. This is t of 2 minus 1 is 1, plus 2 times 2 is 4, plus something. T of 1, remember we said it's in the table and we had to state it as well, which is 3. So 8 equals 3 plus 4 plus something. So that means that 8 equals 7 plus something. So if I subtract 7 from both sides, of course I get that something is equal to 1. So that means that this is plus 1. And that gives me my recursive form. And remember, you can always check your work by using n equals 3 and making sure that it works out using the table. So for this, that means up here, this n, of course, then would be n squared, because you're going to use your explicit plus 2n. So that's your explicit formula. And so we want to figure out on what days the cumulative total number equal to 80. So we're going to say 80 equals n squared plus 2n. Remember, when you're solving something that has a quadratic term, a linear term, and a constant term, you want to set that equal to 0 and solve. So we subtract the 80 to the other side to get it on the other side. So this is quadratic, so we can go ahead and factor factors of 80 that add up to 2. So this is a plus and this is a minus, so that means your signs have to be opposite. So I know this is going to be 10 and 8, but again, if you have a hard time with your factors, remember you can always go ahead and plug it into your y equals to help you. So if we plug this into our y equals and do 80 divided by x, if you didn't know it was 10 and 8, you could, oops, make sure you're on auto. You could use your table to help you look at the factors. So 1 and 80, 2 and 40, 4 and 20, 5 and 16. And then, of course, you would see 8 and 10. So we know this is going to be plus 8 or plus 10 because the middle term is positive and minus 8. And now that we have that, we can set each equal to 0 and solve. So 0 equals n plus 10 and 0 equals n minus 8. So we subtract the 10, we get negative 10 equals n, and 8 equals n. So of course we can't have negative days, so that means the negative 10 is not going to work. So that means n is equal to 8. So that would mean on day 8, Scott's total number of push-ups was 80. So that answers that question. And so notice when you are looking at something that is quadratic for the recursive, notice that my rate of change here is linear. 2n plus 1 is linear. So for something linear, your rate of change is constant. For something that's quadratic, your rate of change is linear. Okay, so let's go to the next page. This year, Scott's plan is to look at the total number of push-ups he completed for the month last year. We're going to use g of n. And to do that, many push-ups each day, m of n, this year. So we've already done the first one, f of n, we're now calling it, which was the 2n plus 1. G of n was, and we actually just did that one as well, so n squared plus 2n. And so notice that we have push-ups each day this year. So hold on a second. Let's go down here and read number 3. How many push-ups will Scott complete on day 4? Write the recursive equation to represent the total number of push-ups Scott will complete for the month on any given day. So here again, we're just rewriting this. We have 3, 8, 15. This would be 24, 35. So again, n squared plus 2n. We already just did that recursive, so I can just go ahead and write that from before. So t of n equals the previous term plus, well, what are we doing with the previous term? We are adding now this quadratic rate of change. So same thing if you go back to this page here. Notice that for when we did something that was quadratic, the answer from the first column where we got the explicit becomes our explicit rate of change over here, or for the recursive. And so that means that this is going to be n squared plus 2n. So the total number of push-ups in the month, so 3 plus 8, so we start off with first with 3, I should say. And then 3 plus 8 is 11. 15 plus 8, 26. 24 plus 15 is 50. 85. And then if we subtract to find the difference. This would be 11 minus 3 is 8, 15, 50 minus 26 is 24, and 35. And then if we subtract again, we get 7, 9, and 11. So those are not the same. So if we subtract again, we get 2, and this would also be 2. So that means this is the third difference. So up back to this one right here. This was the previous term plus m of n. So for question 4, it says how many total push-ups will Scott complete on the for the month on day 4. So for the month on day 4, we can just go up to our table and we can see on day 4 we complete 50 push-ups. It's in our table that we did. Looking at question 5, without finding the explicit equation, make a conjecture as to the type of function that would represent the explicit equation for the total number of push-ups Scott would complete on any given day for this year's promotion. So for this, without actually finding it, we want to just make a conjecture as a type of function. So if it's a third difference, think about the first difference. The first difference was linear. The second difference was quadratic. So the third difference is going to be cubic. Which makes sense because x to the first power is linear, x squared is quadratic, x to the third is cubic. So if we wanted to find the explicit form, we could just use our calculator and plug that in to find an equation. So something that is cubic, remember, is to the third power. So a cubic function would be f of x equals x cubed. That's a cubic function. So for the next part, it says in Scott's March Madness, the function that was generated by the sum of the terms in a quadratic function was called a cubic function. Linear functions, quadratic functions, and cubic functions are all in the family of functions called polynomials, which include functions of higher powers too. In this task, we will explore more about cubic functions to help us to see some of the similarities and differences between cubic functions and quadratic functions. To begin, let's take a look at the most basic cubic function, f of x equals x cubed. It's technically a degree 3 polynomial because the highest exponent is 3, but it's called a cubic function because these functions are often used to model volume. This is like quadratic functions, which are degree 2 polynomials, but are called quadratic after the Latin word for square. Scott's March Madness showed that linear functions have a constant rate of change, quadratic functions have a linear rate of change, and cubic functions have a quadratic rate of change. Use the table to verify that f of x equals x cubed has a quadratic rate of change, then graph the function, describe the domain, range, and intervals of increase or decrease. So 0 to the third power is 0, so we're just plugging 0 in for this function. 1 to the third power is 1, 2 to the third power is 8, 3 to the third is 27, 4 to the third gives us 64, 5 to the third is 125, and 6 to the third is 216. Hopefully you know those. So the first difference, if we subtract 8 minus the 1 gives us 7. So 1 minus 0, I should say first, is 1. 8 minus 1 is 7. 27 minus 8 is 19. 64 minus 27 gives us 37. 61 and 91. The second difference when we subtract, 7 minus the 1 is 6, 19 minus 7 is 12, 18, 24, 30. And if we subtract again, 12 minus 6 is 6, 18 minus 12 is 6, 6 again, and 6 again. So notice that the third difference is the same, which is what makes this a cubic function. So when we are actually graphing the function, x cubed, we do want to graph positive and negative values. So negative 2 to the third would be negative 8. This is not like a quadratic function where when you square a negative, it becomes positive. Remember, if it's negative to the third power, it's negative 2 times negative 2 times negative 2. So this would be negative 1, 0, 1, and 8. So when you graph, we have 0, 0, 1, 1, 2, 8, negative 1, and negative 2, negative 8. Oops, off there. And your graph looks like this. So the domain, we can plug anything in for x is all real numbers. You can see that the range, we also can get positive, negative, 0 out, so all real numbers. This is increasing, so if you go from left to right, notice that the y values are increasing the entire time. So this is increasing over the interval from negative infinity to infinity, and it's not decreasing at all. So question 2 says, using your knowledge of transformations, graph each of the following without using technology. So here, if I want to graph this without technology, the first thing I would do is graph my parent graph. So for my parent graph, we just did that. So that's going to be real easy to just graph what we just graphed. And so we're going to use that to help us for each one. So go ahead and take a minute to just graph it on all your graphs. And now I can use my transformation. So this is not on the inside of the what's being cubed. So remember, when it's not on the inside, that moves it down 3. We look at this one, notice that this one is on the inside being cubed. So that means this is a horizontal movement. So if it's plus 3, remember that moves it left 3. And this one, see if you can do on your own. So this would be right 1. And we have reflection because the negative times something reflects it. So reflect across the x-axis. And this moves it up 2. So down 3 means you would just actually count down 3 from each point. And then you would just graph your graph. Over here, left 3 means we're just going to count left 3 for each point. Oops, it's off. There we go. And here, we're going to move right 1 and up 2. So I'm going to do that right 1 first. Oops. And again, I'm just moving those points from my parent graph. So right 1, and then we're going to move it up 2. Sorry, that color is not a very good color. Probably should have picked a different color, but that's okay. And let's go ahead and do reflection across the x. Whoops, I should have reflected it first. Let's go back a second. sorry, you want to reflect it first and then move it up, because you always want to do horizontal movements first and then vertical, because remember you always plot X and then Y. So this is a vertical movement, but it's a lot easier to do that first. So we're going to reflect it across the X first. So we'll do that in green. So that just means how far away are you from the x-axis. And the reason we have to do that because our transformation order does matter, which we've talked a little bit about. And so this point we come down here. So again, we're reflecting across the x. So how far away is each point from the x-axis? And then you're going to think about if you were to fold this on the x-axis here, this graph here that's in purple would match up with the green. And now we can go ahead and move that up to because if we would have done the up to and then reflection, your graph would look slightly different. And there's my final graph. So go ahead and take a minute to see if you can do D on your own. And then when you're done, you can unpause to check your work. So of course you want to graph your parent graph first. And then remember this 2 is not being cubed. So that, remember, we've talked about before, would mean this is a vertical stretch by 2. Remember that changes your y values. If it was a horizontal movement, it would have to be on the inside cube. So these two equations are different because this one's cubing the 2 and this one is not. So keep that in mind. So that means we're going to multiply our y values by 2 each time. So we have here we have a y value of 0, so 0 times 2 is 0. Here we have a y value of 1, so 1 times 2 is 2. The x value stays the same, we're just moving the y value. Here we have a y value of 8, so 8 times 2 gives us 16. Negative 1 times 2 is negative 2, and negative 8 times 2 gives us negative 16. And then that would give us our graph. And of course you could check using A through E using your graphing calculator. And that's it.